All right, this is the third problem set of the Math Counts school handbook. These questions you are allowed to use a calculator for. All right. All right, so here's the first one. If it was 10:30 now a.m. 55 minutes ago, how many minutes until will it be noon? Ugh. So we start off, it's 10:30 a.m., and that's 55 minutes ago. So you got to figure out what 55 minutes future than that would be. So 30 minutes gives you 11, and then another 25 gives you 11:25 a.m. Now noon would be just subtract 35 minutes away. All right, now this one, fair purchased 4 different items from the list below. The total price of the 4 items, not including tax, was $17.36. What is the difference in the prices of the 2 items that she did not purchase? All right, so the easiest way to do this, rather than just guess and check, is to first figure out what all of them add up to. So if you add up all 6 of these items, you get 27.14. So if you only paid 17.36, you subtract that. So that means you're $9.78 over. So now you just have to go and add these, like pair these off until you can get the number 978. So I tried a few there, and now I realized 349. If you add 349 and 629, that will end up giving you the 978 that we need. So then it says, what is the difference in the prices of the 2 items you did not purchase? So you have to subtract those two, and that's how you get $2.80. All right, now this problem I think was probably one of the trickiest there's been yet. All right, now it's really important to understand this because in math counts they like to ask a lot of questions involving cubes and probability and so forth. All right, so in this case we have a 5 by 5, 5 by 5 by 5 cube that is painted red. So the outside's painted. The cube is then cut into little pieces, 125 of them. How many unit cubes have no faces that are painted red? We can tell there's 100 because 5 times 5 times 5 is 125. Okay, so what I recommend doing is rather than focus on the big cube, start with a little cube and work your way up. And we got to look for a pattern. So for if it was just one cube, obviously it would just be one unit cube, and all of the faces would be painted. All right, now if we had a 2 by 2 by 2, there would be 8 cubes. 2 times 2 times 2 is 8. And all of them are like corner pieces. So each cube would have 3 faces painted. See, 1, 2, 3, 1, 2, 3. They'd all have 3 faces painted, and 3 would not. The inside 3 wouldn't. But there's a total of 8 cubes. Now we get to a 3 by 3 by 3 cube. So that would mean we have 27 total. Now this is where it gets tricky. Well, first, I recommend kind of group the different types of unit cubes. So if we have 27 little cubes, you notice there's 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. Now each of the corners would have 3 faces painted. So we have 8 corner pieces which each have 3. Now let's look at the edges. Now I consider an edge like this piece. Oh, a little too big. Like this. That would be an edge, that would be an edge, that would be an edge, and that would be an edge. So those would be 4 edges. Well, if you look, we have 4 edges there, and then we have 1, 2, and then we'd have 3 and 4 on the left side, so that's another 4. And then we have the back, so there's 12 edges. All right, and that's how we get this and 12 edges, and each one has 2 faces painted. We have 1, 2, 1, 2, and so forth. All right, now the next one we have is the middle piece. See, we have one middle cube, one middle cube. You have one in the center for each of the 6 faces. So you'd have 6 middle pieces, and each of those only have 1 face painted. All right, and that's the whole exterior of the cube. So if you count all those up, we have 8 corners, 12 edges, that's 20. Then we have 6 middle, 26. So that leaves us with 1 inside piece, 1 inside cube left over, and that would have nothing painted because it's stuck in the middle of all the outer cubes. So that's how we get the 1 inside cube. Now let's go 1 bigger. So now 4 by 4. So in a 4 by 4 by 4, we still have 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. Each of those would have 3 faces painted. Now if you look at the number of edges, those are going to go up because you have, I think I messed up in my drawing, but here we have the 4 corners, like there. Now see this right here, we'd have 1, 2 edges that side, 2 edges there, 2 edges there, 2 edges there. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 edges on the front. And then we'd have, on this side, we'd have 1, 2, 3, 4, then 5, 6, and then 7, 8. Basically, you have 3 sets of them. So 3 times 8 is 24 edges. All right, now all we have left is the middle. So in the middle, since it's 4 by 4, the outside is all taken up. Now we look at the inside. We have 1, 2, 3, 4, 4 faces, 4 in the middle, and then you have 6 faces, so 4 times 6, so you have 24 middle pieces. Now you add these numbers up. 8, 24, that's 32. 32 and 24 is 56, I believe. Yes, 56. And so that means the only pieces we have left would be the inside that are totally covered up, which is 8. All right. So now what I'm gonna do is I'm gonna show you the pattern. And again, you might not get it right away, but practice this until you understand it. Basically, once you have a cube bigger than 2 by 2, you're gonna have the same pattern each time. You're gonna have 8 corner pieces. So we have 8 corners, and those each have 3 faces painted. So like in this case, we have those 8 corners. 1, 2, 3, 4, 5, 6, 7, and then that 8th one's hidden. So we got 8 corners. Now the number of edges is always going to be whatever length it is. So like when we had 4, 1, 2, 3, and 4, 4 by 4. See, these outer ones are going to be corners, and those are going to be edges. So it's always going to be 2 less than the length of the side. So like in a 4 by 4 by 4, it's 2 less than 4, which is 2, and then you have to multiply it. There's going to be 12 opportunities for it because you have an edge here, 1 edge, 2, 3, 4, 5, 6, 7, 8, and then 4 edges on the back, so there's 12. So that's why it's n minus 2 times 12. All right, now the inside portion, so the one face that's painted, that's always going to, if you think of like a grid, see we have 4 by 4. So I'll make my... All right, now at this time, we've already counted for the 4 corners. Those are done. And we've also counted for the edges. Those are done. Now, if you look, what's left is always going to be, see, we started off with the number 4. 4. Now, when we took off, see, we took off one edge here, we took off one there, we took off one down there, one there. So you take off 2 from each side. So that's why it's n minus 2. So it's 4 minus 2, which is 2, and then squared. So it's always like a little square. So we have 1, 2, 3, 4. That's why we have 4. And then there's always 6 faces, so you multiply that times 6. All right, and then what we're going to be left with, always in the end, is basically when we've taken off all these 2 from each side, we take off the front, we take off the back, we take off the left, we take off the right. In the inside, like imagine it's an outer shell of a cube. So these numbers all represent the outside of the cube. All right, then we're left with this inside, which is basically untouched. It's like an inner cube. The inner cube is always going to have a side length of 2 less than the outside, and that's basically we're taking off the outer shell, if you can imagine that. So in the inside of like, it's always going to be n minus 2, but it's volume, so you do that times itself 3 times. And then when you add all these up, it'll always equal the 3 numbers multiplied together. So for example, now we're on a 5 by 5 by 5, and it's saying we want to know how many are not painted. So that's specifically talking about the inside. So the inside of a 5 by 5 by 5 is going to be a 3 by 3 by 3 cube. So it's 3 times 3 times 3, which is 27 faces are not red. I would encourage you, practice this problem with bigger numbers. This is a really good problem to learn about.